Hello everyone. Now let us discuss about the next abstraction level in our Verilog HDL, that is behavioral modeling. It is one of the RTL that is used to model our hardware circuits or our hardware designs. As we know that in the complexity is day by day getting increased, and the number of functional blocks or modules which are going to be placed on the chip is also getting increased for the digital designs. So now it is a crucial time to pick the correct RTL to model our hardware designs. As in the diagram you can able to see the number of blocks. I can able to find program controller, program memory control unit, etc. So these many number of blocks are placed on a single chip. Hence, in order to provide more number of functionalities. So is it a good idea to use still a structural abstraction, or can I use the data flow abstraction to model my hardware design of each and every functional block here? No. So the very next abstraction level is behavioral modeling. With the behavioral modeling, we can have enormous number of advantages in modeling or designing any hardware circuit. What happens here is the architectural evaluation in before abstraction level were taken by using a logical gates or by using a data flow, like how the data is flowing between the registers. But coming to here, the scenario is entirely different, where the architectural evaluation takes place at an algorithmic level, such that the designers now no need to think about picking the logical gates and interconnecting them, or data flow, like how the data is flowing between one module or one register to other register. All these headaches will be getting erased. So now the designer mainly concentrate on algorithmic level. That means by using this algorithmic level they are going to implement in hardware also. So the designers here are more concerned about the behavior of the algorithm such that it is meeting the functionality of your block or a module, and the algorithm whatever you are writing, is it achieving the good performance or not. So this is why the behavioral abstraction came into picture. The behavioral modeling is nothing but it is a very high level of abstraction when compared to the two abstractions which we have discussed in the previous sessions, such that the designers at this level will be designing a program that resembles like a C programming in syntax, more than it resembling like a digital circuit design, like picking the logical gates or how the data is flowing between the registers. It won't represent in that manner. So the program whatever we are going to write here, it entirely represents or resemblance like a C programming structure. Okay, now so in the behavioral abstraction we do have two main basic statements. As in the data flow we have seen, assign is the very most important keyword which is helpful in designing any hardware. And similarly in our gate level modeling or gate level abstraction, we do have the primitive gates or the logical gates. Okay, these gates are already predefined to the compiler. Similarly, the assign keyword was predefined to the compiler. That means the compiler can able to understand as it is already getting predefined. Okay, and the next one here is in the whenever we are writing any hardware program in behavioral abstraction, the two most important keywords which plays a crucial role are initial and always. We generally call these initial and always as procedural statements. Okay, let us discuss each and everything one by one. So I am having here a design that is 4 cross 1 multiplexer. So if I want to design in the gate level abstraction, I need to write this much heavy code. Like I have here 4 AND gates, 2 inverters and 1 OR gate. So the functionality should not be getting disturbed. So what is the functionality of the 4 cross 1 multiplexer? The output will select one among the 4 inputs. Okay, so based on the selection line. So this is the functionality. So the functionality will be given by the truth table. So whatever the thing I am going to write here, it should meet the functionality of the design. So this is the program code I have highlighted here. So module marks for down 421 output, inputs and selection lines. So all these things you can able to understand. And if I would like to design using data flow structure, data flow design, this is the code how it will be. I have used here assign as a keyword, which is playing a most important role here. And here also in the gate level abstraction, all these primitive gates playing a crucial role in developing any hardware circuit. Coming to the 4 cross 1 multiplexer in behavioral abstraction, I haven't used or picked any logical gates and I didn't use any assign as a keyword. So I just followed a logic of the 4 cross 1 multiplexer. I have written the program such that this program is meeting the functionality of my 4 cross 1 multiplexer. So as I have mentioned that I will be using two most important keywords in behavioral modeling, that is initial and always. So here I have used always. You can able to see here. So let me have module name and ports declarations. This is inputs and this is output. Whenever I am using behavioral modeling for design, I exclusively represent my output variable using reg as a keyword. Okay. After that, always, that means completely, always, forever, I am depending on the inputs at the rate, always at the rate. What are the inputs here? I0, I1, I2, I3 and select. So select, it is I have taken here, instead of select I can simply go with yes also as a variable. But here select is not a scalar quantity, it is a vector quantity because I have declared select variable in terms of a vector, that is 1 down to 0. That means select of 1 and select of 0. So it is a 2-bit quantity. Now, so like case select. So if this is a 2-bit quantity I have mentioned, if yes, let me go with s of 1, s of 0. That means s1, s0. If s1 and s0 are 2-bit binary 0, 0, what will be the output? Output will be following input I0. And if it is 0, 1, output follows I1 and similarly I2 and similarly I3 end case. That means as I have written the code in this way, that means I am meeting the functionality or the truth table of my 4 cross 1 multiplexer in this manner. As you can able to see here, when the selection lines are 0, 0, I0, 0, 1, I1, 1, 0, I2, 1, 1, I3. That means this is my case expression. Based on this expression, one of the best alternative will be picked and that will be evaluated as an output. So this case and case, these are the terms case statement. We have came across this kind of programming in the C language. So as I have mentioned that programming the any hardware design in behavioral abstraction, resembling like a C programming language. So this is nothing but an algorithmic way of designing a hardware circuit or a hardware design. So we can able to see a few more examples in the further slides, and let us discuss some of the few terminologies that are most essential and playing a vital role in modeling any hardware designs. So the first and the foremost thing here is structured procedures. So what are these structured procedures? These structured procedures are very important in designing any hardware. As I have mentioned, the two most basic statements are always and initial. Like all the statements whatever I am writing here, let me call them as a behavioral statements, and all these behavioral statements definitely will be occurred only inside the always or initial blocks only. That means they will be appearing only inside this structured procedures. You can able to see here. So these are the behavioral statements, and these are present under the always block. But we know that our Verilog HDL is not a sequential programming language. As discussed in the previous session, it is a concurrent programming language where the activity will flow or it will run in parallel rather than in a sequential manner. Okay, so always and initial statements represents a separate activity flow where each activity starts at simulation time 0. That means here always block, like for example I am having some statements here. These statements comes under the always block. So these similarly I will be having somewhere else initial block statements also. So all these behavioral statements which comes under always block or initial block will be getting simulated or will be getting started simulating at time 0 seconds or 0 time units. So let us discuss uh, this statement in brief. Okay, so here I have taken two initial blocks. So the initial block I have taken. So initial, I am having multiple number of behavioral statement. Okay, so if I am having multiple statements means definitely as I have to use begin end as the keywords. If I have only single behavioral statement, I don't require to use begin end. So for first 10 after 10 seconds, that means as 10 after 10 seconds my clock variable will be having logic 1. After 20 seconds my clock is having 0. After 30 seconds it is 1, and after 40 seconds it is 1 bit binary 0. That means the second statement will be getting executed only after the execution of the first statement. So the first statement when it is getting executed, that means immediate, of course I have mentioned that all the initial or the always block will start simulation at time 0 time units. I meant to say the activity flow starts at simulation time 0. Then you might be getting a doubt, sir, clock equal to 1 bit binary 1 should be getting executed at time equal to 0 time units. But here what will happen? I have kept a delay before the clock. So clock variable is now waiting for 10 time units. After that this statement will be getting executed. Now the second statement clock equal to 1 bit binary 0. When it gets executed after 20 seconds, that means 10 seconds plus one more 10, that is 20 seconds. After 20 seconds clock equal to 1 bit binary 0 will be getting executed. In this manner initial statement will follow. So what about this always? So this always statement is nothing but, as discussed, the statements which comes under the always That means all the statements are nothing but always block statements. So even though the always block starts at time 0 and executes the always block statements continuously in a looping manner. Okay, so like it is, these statements is like to model a block of activity which is a continuous form. For better understanding, we can take a clock generator module. So a clock signal is a continuous flow. That means once the clock is started, I don't know when it is going to stop or when it is going to be terminated. Okay, that means it is a continuous activity. Let us discuss these always and initial by using the Xilinx tool. Initial and always. So I have placed my code here for initial and always. You can able to see here. So what is happening in this case is I have the test bench name module tb and xyabm, some random variable, some variables I have taken which are of type registers. Okay, initial dollar monitor. That means why I am using here dollar monitor, to continuously monitor the status of the variables like x, y, z, a, b. For this purpose, like what are the values these variables are being assigned. So to continuously monitor these variables, I am using dollar monitor. So here m is a scalar quantity, single element. So if this is a single element means I said it is a behavioral statement. Only single behavioral statement is there. No need to use exclusively big and end keywords. And similarly a and b. So these a and b are still present initial under the initial block. So these are the behavioral statements, but I am having two, more than one. I definitely have to use begin and keywords. Similarly, I do have x and y variables. So these x and y variables are also placed under the initial block. These act as an, or you say, behavioral statements. So two are there, begin and keywords I have used here. Like how you are going to use the curly braces in the C language, similarly in the, here also we are going to use begin and. Now initial #50 $finish. So what will be the expected outputs? As I have mentioned, always and initial block starts activity, simulation activity will be starts at time 0. That means at time 0 m value will be assigned. Okay, at this time a value, b value, x and y will not be getting executed. Okay, so after waiting for 5 seconds a value will be getting executed. That means now I am having m value, I am having a value. I don't know what is b, what is x, what is y, right? So after 10 seconds, because as I have said you, each initial block will execute parallelly. That means this initial block will start at time 0, this initial block will start at time 0, this initial block also will start at time 0. You can able to see here. So let me execute the program and we'll see. So I am once again telling that each initial block will start at time 0. That means this will be executed at time 0. A will be executed at 5 units. B will be executed at 5 plus 25, because these are the sequential statements. 5 plus 25 is 30, and this is a, of course this is initial block and it starts executing at time 0, but x have to wait for 10 seconds as I have given here the detail. That means 10 seconds. So y will be executed at 35 seconds. So 35 after 35 is the largest time. The That means here y variable is taking the largest time to produce its output. So that means after 50 time units the simulation will be getting terminated. So let me check whether I am getting the same thing or not in the after simulating the code. Yeah, so as I have told you that m will be executed at time 0. You can see here, yeah, m will be executed at time 0, where at time 0 the a, b, x and y value are undetermined. Okay, and at 5 seconds a will be producing the output where the status of the remaining variables will be unknown, but I know the status of m variable, that is 0. And at 30 so next to execution at 10 seconds, so at 10 seconds x value will be getting produced. So you can able to see here where b and y are unknown, and after 10 seconds what is the next time? 30 seconds. So after 30 seconds what happens? B value will be getting executed, that is b equal to 0. You can able to find here, and where y value is still unknown, that is why at 35 seconds, after 35 seconds, so I will be getting the determined value for y, that is y equal to 1. So when the simulation is getting to be stopped at 50 nanoseconds. Why it is stopped? Because the hash $50 finish at 50 time units I have terminated my simulation. In this manner it follows. Okay, so this is about initial block. That means you need to remember here all the initial blocks will start, all the initial or all the always blocks will start its activity of simulation at time 0 seconds. Now let us discuss about the always block. So the perfect example for the always block is clock generator circuit, as I have already mentioned you. So this is my clock generator circuit. So initially the thing is, initially I am going to give what will be the value for a clock, because clock is a variable. What variable? It is an output variable and it is of type reg. Okay, now so here initialization of clock is always must. Let me check how the code behaves now. I have got many number of outputs. Okay, so what is happening in this code is initialization for a clock should be done compulsory inside a separate initial block or a separate initial statement. Like for example, if I put the initialization of clock, that is clock equal to 1 bit binary 0. This statement I have placed inside an always block. For example, like this, cut. If I place it like this, okay. So if I place it inside the always block, what the initialization of a clock will be getting initialized every time as the always, as it is present inside the always block. Okay, so once it is present inside the always block, it is getting initialized every time, and the simulation will not be getting advanced. Okay, so this is the wrong programming style. So this is the right programming style. Where what happens here, initialization of a clock is compulsory. Okay, at time 0, that means clock equal to 1 bit binary 0 will be getting executed. That means clock variable is going to produce the output 1 bit binary 0 or logic 0 at time 0 seconds. And in always block, what happens, always blocks also start getting like also getting activity of simulation at time 0 seconds. So after 10 seconds, the variable clock will be having a value of 1 bit binary 1, because the previous value of a clock is 1 bit binary 0, and here I have used negation symbol. So after 10 seconds, my clock variable will be having a value of 1 bit binary 1. That means for every 10 seconds, my clock variable is getting toggled. That means toggling of a clock occurs every half cycle. If I consider the time period of a signal as 20, for every half cycle, the clock variable will be getting toggled. So for how long it will be getting toggled? At somewhere I should stop the activity of a clock, right? That means the activity of a clock, if I want to stop, means separate initial clock I am taking here. So after 1000 seconds or at 1000 seconds, dollar finished I have used. So dollar finished I have used means I am completely terminating the simulation. So you can able to see here at 0 seconds clock equal to 0, and at 10 clock equal to 1, and at 20 clock equal to 0, at 30 clock equal to 1. So the clock is keeps on toggling for every 10 seconds or 10 time minutes. So when it is going to stop at 1000, so you can able to find 990. At 990 clock equal to 1. At 1000, what I have done, I completely stopped the simulation. So this is what the initial and always block description is. Okay. So the very next one, we are going to discuss about the remaining terminologies in our behavioral abstraction is procedural assignment. So you people are good, having good awareness on the assignment operator or the assignment symbol, which you have learned in your data flow abstraction. So similarly, we do have a requirement of using the assignment operator here, of course, right? So normally in the LHS of your assignment operator can be a register, integer, or a real variables. So the value placed on a variable, that means left side, will remain unchanged until another value is kept on that variable, or until another procedural assignment is updating the variable with a different value. So here, let me take the same example. I will give you one more example here. So x equal to 0 here I have placed. So that means this x variable is storing or a value of logic 0. Now this variable value will not be getting disturbed until and unless I update the variable with some other different value, like x equal to 0 to x equal to 1. So in this manner. So this is about the, one second, sorry. So this is about procedural assignments. Okay. So the RHS, you know that as you have learned in the data flow abstraction, the RHS of your assignment operator can be any expression that is going to evaluate some value, and that value will be assigned to your variable that is present in the LHS side of your assignment operator. Okay. Now these procedural assignments can be categorized into blocking statements as well as the non-blocking statements of non-blocking assignment. So what are these blocking assignments and non-blocking assignments? We'll see now. So this is the assignment operator, that is we use equality sign. So what happens in the blocking assignment statements? Normally these are executed in the order how they are specified in a block. Now, like this is my block. Okay, so these are the sequential block. A blocking statement will not block the execution of the statements that follows a parallel block. Okay, for example, I am going to take here an assignment operator equal to here. So this assignment is blocking the other assignments until its execution is getting completed. So that means D2 equal to D1. So until its execution is getting completed, D3 will not be getting the value. That means I have D1 some value. The D2 will be getting the value of D1. So immediately the second statement will be getting executed. After that, third statement will be getting executed. That means the D3 value is assigned to D4. After the D3 is receiving the value from D2, the D2 will be given to D3 after receiving the value from D1. So it is a step by step the execution will be followed. Okay, so now my question is, will the code work? Okay, so just answer for this question after having a after running a simple program code indexing tool. Okay, now along with it, what is this non-blocking assignment? As I have mentioned you that procedural assignments are of categorized of two kinds, blocking and non-blocking. So this, for the blocking assignments we use the equality operator, and for the non-blocking assignments we use the less than equality operator. So the less than equality operator speciality is, that means third statement should have to wait for the second statement execution, or fourth statement have to wait for the third statement execution. Nothing, no protocol should be followed. That means each and every statement will be getting executed independently to each other according to its simulation time. That means if I have mentioned here delay, all the statements will be getting executed parallelly. That means no statement will depend or will wait for some other statements execution. Okay, so similarly here the scheduling of assignments without blocking execution of the statements is done here. Like the execution happens how here is, the RHS of the non-blocking statements at the beginning of the time step update the LHS of the non-blocking statements at the time step. So let us discuss what are these 2 points here. Before discussing the 2 points, I have here some code. What is this? So blocking statement is, we are going to use the equality operator, and non-blocking statements means less than or equal to operator. So A equal to 1. After A is receiving the value of 1, B will be receiving, and next C will be receiving its value. But in the non-blocking assignment statements, all will be starts executed at time 0. Okay, but parallelly they will be executed. Like at time 0 A equal to 1, but like B and C, I cannot able to tell what are the values of B and C. Okay, So let me demonstrate you this non-blocking and blocking assignment statements with some programming code, and such that you will be having a clear idea on that. Okay, so I have taken here three variables, that is xyz, which are the scalar variables, and one count is an integer variable, and a and b are the vector variables. So here what I am doing here, I'm just scalar assignments, that means assigning some value to all the scalars, and next assigning some value to my integer variable. Next similarly for here what I am doing here is like a equal to 16-bit binary 0 and b equal to a. That means the vectors are also getting initialized here. So immediately what I am doing in this way, in this one, assigning, so like it is a vector part select, a part of a vector. A is here a 16-bit vector, that is 16-bit binary zeros, all 16 bits are of zeros. So among the 16 bits of a part select, that is a of 2, I have given as 1-bit binary 1. When I have assigned a of 2 equal to 1-bit binary 1 after 15 seconds. Okay, so now what I am doing in this statement is after 25 seconds, that means 15 plus 20 to 10, that is 25. B's, that means b vector 15 down to 13, that means 15 to 14 to, and 13 to bits of b vector will be getting updated with a new value, that is xyz. So this is nothing but the concatenation of xyz. So what is x? 0, y is 1, z is 1, 0 1 1. So that means 15 to bit is 0, 14 to bit is 1, 13 to bit is 1. So clubbing in this manner is nothing but concatenation as discussed in the data flow abstraction. So the part select, that means in a vector B I have picked 3 bits, that means a part of a vector I have picked and assigned with different and with updated values to those 3 bits. So after this one, after 25 seconds, B will be getting executed. Similarly, count equal to count plus 1. As the count is assigned with 0 initially, now count will be getting the value updated to 1. So here what is happening means y equal to 1. Here I am having this will be executed only after the execution of this statement, because it is a sequential block, as I have said you, sequential block, and the operator, the assignment operator is a blocking operator, blocking assignment operator is the one what I have used. That means y equal to 1 will be executed after x equal to 0, and z equal to 1 will be getting executed after y will be getting executed. So the behavior in the block of begin end should be executed only in a sequence manner. Okay, now let me check with the output. So what is my suspicion is a of 2 will be getting updated, that means a vector will be getting updated after 15 seconds or 8 to 15, from 15 seconds onwards, and b vector will be getting updated from 25, 15 plus 10 is 25 seconds, and this is also after 25 seconds, but this statement will be executed priorly. After that count will be getting updated. So where I have done right. Okay, of course you can able to see in the waveform window also, no issue. But Let us observe in the simulation in the console window the outputs. Okay, so at 15, so at 15 a value will be getting updated, so you can able to see a value is changes, and after 25 b value as well as count will also be getting updated. So thing is I didn't use the count variable at a time of, yeah, I have to use count equal to percentile b or percentile d I can use, and comma count. If I use like this in the dollar monitor argument list, I can able to view what will be the updated value of a count. In this manner the blocking assignment statements will be getting executed. So similarly, how the non-blocking statements will be getting executed, let us see. So these are the non-blocking statements. X, Y, Z similarly the same variables, and these are the two vectors, register A, register B. Integer count is a variable of type integer, and so initial begin x equal to, so here and here up to here I have used blocking assignment operator, and from here to here I have taken non-blocking assignment operator. So that means reg B will be executed after reg A. Reg A will be getting executed after count, and this one will be executed after Z, Y, and X. So, but coming to here, reg part select of a vector A, that is register vector A, reg A vector, A of 2 equal to 1 bit binary 1. And similarly XYZ, the concatenation of XYZ will be making the B highest 3 bits updated after some amount of time. And similarly A of 2, this portion, this bit of A vector will be getting updated only after certain portion of time. So that means here using the non-blocking assignments, where the execution activity flow starts parallelly irrespective of other assignment statements. So if I have placed here, instead of hash 15 I have placed it like this, and hash 10 I don't have anything here also. That means these these execution will start at time 0 seconds onwards, and this execution also starts at time 0 seconds onwards. But I don't want like that, because I need to receive some values, that is xyz values I need to receive. After that only, that means similarly here also I need to receive what is the a of 2 value. After that only I want these two statements to be getting executed. So that means here a of 2, the second bit position of vector a will be getting updated after 15 seconds. Similarly, the highest 3 bits of vector b will be getting updated after 10 seconds. So that means as soon as I start the simulation at 10 or from 10 seconds, b value will be getting updated, and from 15 seconds a value will be getting updated. So these three follows a blocking assignment operator, and these two follow a non-blocking assignment operator. Let me check here. Am I getting the same output or not? So what about the count variable, when it will be getting executed? My suspicion is 0 seconds, because non-blocking operator I have used it here. That means this statement will not or will never be waiting for some other's execution. It will execute as soon as it receives something. Okay, let me check the output. Yes. So at 10 seconds I got my updated value for B, and at 15 seconds I got my updated value for A. This is the B at 10 seconds and this is the updated value for A, that is at 15 seconds. Count I didn't display here, even also you can able to see count. Where is this count? Yeah, count is here. So from 0 seconds the count value will be equal to 1. You can see like yeah, this is 1 from 0 seconds onwards. Okay, this is about non-blocking and blocking assignment statements. So we do also have the timing controls, which also plays a vital role in modeling any hardware design or a hardware circuit by using the behavioral abstraction. So these timing controls are nothing but these provide a way to specify the simulation time at which procedural statements have to be getting executed. Like we many times came across the delays, and when a particular statement will be getting executed will be completely depending on the amount of delay that we have given or we have taken for our program or for our statement. Okay, so these delay based timing controls, like for example I am having an expression like which specifies the time duration between when the statement is encountered and when it is executed. We use mainly the delay symbol by hash, that is a number symbol. Now we do have three types of delay control statements for our procedural assignments. One is regular delay, event based delay control, and sorry, we do have timing controls, not timing controls. One is a delay based timing control, and the second one is event based timing control, and third one is level sensitive timing control. Of course, in each and every timing control we do have also the subcategories which are highly essential to specify at what time particular procedural statement will be getting executed. Okay, so let us discuss about a delay based timing control in brief, and after that we can move to the next two types of timing controls. So in this delay based timing control, the expression I am having in my statement, like for example in an expression specifies the time duration between when the statement is encountered and when it is getting executed. Like for example a equal to b plus c is there. B plus c is nothing but it is an expression, and this a equal to b plus c I simply written. As soon as b plus c is getting evaluated, the evaluated value will be given to a, and the a will be getting executed. For suppose if I have maintained like this hash phi a equal to b plus c, that means b plus c will be handing over the value to a, but a will be waiting for 5 seconds to get executed. So in this manner the statements will be getting executed. Okay, so we do have in the delay based timing control, one is a regular delay control, intra assignment delay control, and the next is the zero delay control. So in this regular delay control, definitely I am going to use a non-zero delay that will be present only to the left of your assignment operator, which may be a blocking assignment or which may be a non-blocking assignment, I don't know. Whatever the thing is, the delay should be present in the left hand side of your assignment operator. In the intra-assignment delay control, the delay should be present on the right hand side of my assignment operator. In the zero delay control, it is a specific case which will be used to eliminate the race around condition. Like for example, I'm having here like sum equal to a x or b, hash to carry equal to, that means here for carry to be will be executed after waiting for 2 seconds, 2 time units. As soon as a and b value, a and b will be evaluating the expression value will be assigned to carry, but carry will be getting executed after 2 seconds. That means delay is present in the left hand side of your assignment operator. In the intra assignment delay, the delay is present in the right hand side of your assignment operator. But coming to the zero delay control, I have received a value and b value somewhere in the code. So sum and carry I have calculated. And here also I am having sum and carry in the separate one more initial block I have taken. So these two initial block will start getting simulated at the same time. Now the thing is, for suppose okay, let me take a better example with program code and demonstrate you. Okay. This is step by step I am coming, so don't worry. This is pasting here. Let me save. Let me run. Yeah, something happened. Okay, so just open it. Okay, so the module name I have taken here is RDC, that is regular delay control, and like I have taken parameters called latency and delta. Whenever latency and delta are found in your program code, those are being substituted their values, that is 20 and 2. So parameter defining the parameters have done here itself, and these x, y, z and p and q are nothing but they are the scalar variables. So here I am defining x, y, that is register variables I am defining here itself, x equal to 0, and after waiting for 10 seconds I am defining what is my y variable. Okay, so immediately hash latency z equal to 0. So here x equal to 0, you can see there is no delay control. For y equal to 1 I am having a delay control. So this delay control is controlled by a number, that is 10 time units, and here z equal to 0 will be getting executed by maintaining certain delay, and this delay is controlled by an identifier. So here it is nothing but it is an identifier. So delay control with identifier of how much time? 20 units. Let me write here. Identifier is controlling delay. Identifier delay. Let me write like identifier delay. So latency plus delta. These two identifiers are clubbed with some operator. That means whenever like operands are clubbed with an operator, we are going to get an expression. That means here the delay control is controlled by an expression. And similarly here q equal to 0, that means here the delay control is controlled by using a delay value, that is a minimum, typical or maximum. So I guess as phi q equal to 0 will come into picture. Why? Because always typical value have to be taken into consideration. So let me check. So y will be at 10 and z will be executed at 10 plus 20, that is 30 seconds. because 10 latency is 20, and this is how much, 30, 20 plus 2, 22, 52, because 20 plus 2, 22 plus here 30 I am having, so 30 plus 22, 52, and this is 52 plus what is the value, 53, this is because y value is 1, and 53 plus this is 58 seconds. Okay, let me check. 10, 30, 52, 53, 58. Yes, 10, 30, 52, 53, 58. Yes, exactly the same thing I have produced in the output. That means these statements will be getting executed at different time units. That means all the statements, one statement is controlled by using an identifier, one is a expression is controlling the delay, and a number is controlling the delay, and an identifier is controlling a delay, and a minimum, typical or maximum value is controlling a delay. In this way the regular delay control can be discussed. So moving to next one, it is an intra-assignment delay control. It is very simple one. So here in the intra-assignment, before we discussed it was inter-delay control or regular delay control we can call. Now it is intra-delay control, where the assignment, where the delay should be present on the right hand side of your assignment operator. That is y equal to #5 x plus z. Let me run. So x plus z will be evaluating its value, and that value will be assigned to y after 5 units. So this will be getting evaluated at time 0 only, but immediately the value will not be getting assigned to y. So this 0, whatever this value 0 will be given to y after 5 seconds. That means y will be getting the value only after 5 seconds. Simply I can say that I will be taking the value of x and z at time 0, evaluating the x plus z at time 0, and then waiting for 5 seconds. After 5 seconds the evaluated value is assigned to y. Yes, so y value previously I don't know, y equal to x here. After 5 seconds y equal to 0. This is the value what I have got. You can even observe here in the waveform window. So here after 5 seconds, that means y status is unknown up to 5 seconds. From 5 seconds onwards its status is logic 0. In this manner we can able to analyze. Okay, and the next and the last one is so here I will explain this program here itself. Zero delay control. So I am having here two initial blocks. So these two initial blocks will start execution independently to each other. Like this will start simulation at time 0, and this also will start simulation at time 0. So the simulator won't understand, like if I don't have like here I don't have any delay here, like the simulator will not understand what is the output that x and y have to be produced. Like x equal to 0 will be displayed as an output, or x equal to 1 will be displayed as an output, and y also same, it will be 0 or 1, what will be the value of y. It is in like I can say not determined or indeterministic. Like so zero delay control, it is a special case, or it is a method actually, such that whenever any statement is having a zero delay controls, like here these statements only will be getting executed lastly. After all the statements will be executed in the current simulation time. So such that the race around condition, that means x equal to unknown and y equal to unknown, this race around condition can be eliminated, or non-deterministic conditions can be erased easily. So this is the advantage of using the zero delay control. Okay, now this is about zero delay controls. Okay, so the next category of the timing controls is event based timing control. So what are these event based timing control? We'll see. These event based timing controls completely depending upon an event. Generally an event is nothing but a change in a value for a register variable or a net variable, or an input variable or an output variable. If its value is getting changed, some event is occurred. Like for example, in the month of from the month of March, we have got an event, that is lockdown. So before March we don't have any, and from March onwards some event is occurred. So lockdown event have generated, and certainly we got stuck ourselves in our respective homes. So this is our executed output, that is keeping ourselves in the home and maintaining the social distances. All these are nothing but executed, the statements which are under execution. These statements which are under execution is completely dependent on an event, that is corona, because of which lockdown. Okay, so similarly an event is nothing but, in coming to the digital part of view, it is a change in a value on a register or a net variable. So whenever events are happening, or whenever they are occurring, they are utilized to trigger the execution of statements. As I have said you, the execution of statement means like stacking at homes and maintaining the social distances. All these are nothing but these statements are have got executed. So let us discuss what are the event based timing controls in our behavioral abstraction one by one. First is regular event control, next is named event control, and the last one is event or control. So regular event control is the notorious and very well known event controller. It is where we use iterate symbol, that is used to specify this event, and the statements which are under this regular event control can be executed only on changes in signal value, which happens either at a positive edge of a clock or a negative edge of a clock, or a positive edge of a signal or a negative edge of a signal value. Like I am having clock is a signal, and the signal will be definitely going to have a value which may be a 0 or which may be a 1. Like always either at positive edge of a clock, my output I will follow completely input. The output will follow the input only under the positive edge of a clock. If the clock is having a negative edge of a clock, the previous value will be sustained. That means the output will not take the incoming input data. So here passage is nothing but it is used for a positive edge of a clock, positive edge of a signal transition. We use the keyword passage. So next is event or control. So what is this event or control? Is nothing but I may have sometimes always at the rate I need to completely depend on, always I have to depend on the inputs. The input may be a reset clock or data input D. So whenever any of the input having a transition or it is undergoing any transition, some of the statements have to be getting executed. Like a transition on any one of the multiple signals can cause the triggering or the execution of statements or a block of statements. So for example, I am having here in my sensitivity list reset, clock or day. These are the three signals, and if reset, which is the highest topmost priority interrupt reset, that means q equal to 1 bit binary 0, output will be they are fixed to 0. And else if that means clock is present and the reset is absent, for suppose, that means clock which like for example clock is having undergoing some transition, like clock is high, so else if clock is high, so the output will be receiving the input incoming data. So in this way event or control can be discussed. Every time we no need to use or word here. Instead of or we can also use comma, that is a reset comma clock comma day. That means one any one of the transition is happening, any of the transition is happening among these three signals, execution of a statement can happen. That means like reset, clock or the, if these three signals are generating some event, the corresponding execution of the statements will be executed. So this is about event or control. And the very next one is named event control. So what it does actually is it generally provides the capability, that is like to declare an event and then trigger and recognize the occurrence of that event. Like for example, event increase in the corona cases. Okay, so event is an increase in corona cases. Always I'm depending upon the statistics. Begin, for suppose always I'm depending upon the statistics of the corona cases. If the corona cases margin is greater than 10, implement the lockdown. If the else if no need to implement any lockdown and take certain precautions. That means event here is nothing but number of corona cases. Always I am depending upon the statistics of corona cases. If the number of corona cases are greater than 10, implement a lockdown. So in this manner we can able to like analyze how this named event control can be understandable. Like in that subject point of view, I have an event called received data. So that is event is received data always at the rate positive edge of a clock. That means only at positive edge of a clock I will be accepting the input data. Okay, begin if last data packet. So all the data packets have been sent and it is the final or the last data packet. If it is the last data packet, an event should be getting executed, right? So what happens? I am triggering what? Triggering the event received data. So all the data packets I have received completely. So this is my triggered. So once I have got a trigger symbol, that means OK symbol, that means my done symbol, that means always at the rate of received data. Okay, this is my triggering input. I have a output data buffer register, which is a vector register, such that it is storing all the incoming input data packets like data packet 0, data packet 1, data packet 2 and data packet 3. So here I can able to describe you that I have declared an event received data, and this received data whenever it is triggered. So when it is triggered, if it is a last data packet, this event got triggered. As soon as this event got triggered, like always at the rate received data, so and recognize the occurrence of that event. So this recognizing the occurrence of that event means last data packet. Whenever I am recognizing it is a last data packet, I have recognized it, then the event is getting triggered. Once the event is getting triggered, some block of statements have to be getting executed. That means declaring an event, recognizing the occurrence of the event, triggering the event. Once the event is being triggered, some statement have to be getting executed. In this manner it follows. This is about named event control. So, and the last one is level sensitive timing control. So what is this level sensitive? As we completed delay based timing control, event based timing control, now the last one is level sensitive timing control. So iterate is normally used for regular event, right? Now similarly we do also have here like iterate for mainly positive transition or a negative transition, positive edge of rising edge or falling edge of a clock. Similarly, there will be a level like logic 1 or logic 0 for any signal like a clock or some A signal or B signal or whatever it is. Like however we are going to have the positive or negative. Similarly, for positive or negative or like leading edge or a trailing edge. Similarly, there will be a level sensitive timing controls which completely depending upon the status of your variable, like it is in logic 1 or logic 0 status, where the symbol iterate we have used further, but our Verilog language here it is allowing us a level sensitive timing control, that is nothing but to ability, it is having an ability to wait for a certain condition or a certain variable or a certain signal or a certain register to be of true before a statement is getting executed. That means always instead of iterate I am having wait, always wait, because it is a level sensitive timing control. Wait, when count enable is, that means whenever this variable is of logic 1, execute this statement. Immediately will it be getting executed? Never, because I am having again here as 20 count equal to count plus 1. That means after 20 seconds count equal to 1. If initial value of a count I have taken as 0 means, that means after 20 seconds count equal to 1 will be getting updated. So that means always wait for your signal or a variable is of logic 1. Whenever this variable is of logic 1 state or true condition or true state, the succeeding statements have to be getting executed. So this is about level sensitive timing control. So this is these are the some of the topics in our behavioral abstraction. In the next session we are going to study about the conditional multi-way branchings and some of the blocks like sequential parallel blocks in our behavioral abstraction modeling style. Okay, thank you for the day.